Good afternoon. Today we will continue discussing the structure of production in autarky, and you will see at the end we will prove two of the theorems, that is the Stopler-Samuelson theorem and the Rybinski theorem. The Stopler-Samuelson theorem says a rise in the price of a commodity raises the real reward of its intensive factor and a decline in real reward of its unintensive factor. That is the Stopler-Samuelson theorem, which came way back in 1949 to prove that how trade has unequal effects on the factor returns. Rybinski, on the other hand, tells about the relationship between the factor supplies and the outputs, and it says an increase in supply of a factor keeping the relative prices constant raises the output of the commodity, which uses the expanding factor relatively intensively, and a decrease in the production of the other commodity. Now, to prove this, you have to first define the basic structure of the model, and so we will start with the full employment conditions and also assume that there is perfect competition in the product markets. Now, if there is perfect competition in the product market, prices will be equal to average cost. So, we will start with the basic model and then we will discuss the equations of change. So, here the proof is a little long, maybe it will extend to the other lecture tomorrow, but we will start with the very basic model and then we will do the equations of change, and that will finally give us the proof of the Stopler-Samuelson and the Rybinski theorem. So, then the full employment conditions L1 plus L2 is equal to L. There are two commodities which are produced, 1 and 2, and some labor is used in production of good 1, some labor is used in production of good 2, and this totally exhausts the total amount of labor, which is L. There is capital, there is the second factor of production which is used in the production of good 1 and good 2. So, K1 plus K2 is equal to K. Then there is the condition that prices are equal to the average cost. Now, this would mean this is the total cost divided by the output. This prices are equal to the average cost for the other good, it is equal to this. Now, prices are equal to average cost when you assume long run and it is perfect competition. So, prices are equal to average cost. Now, if you work further on this, you can find out the unit labor requirements, unit capital requirements, so this gives me and so Cij Cij is the input, this is the input output requirement. You can well understand it as unit labor requirement or unit capital requirement, because it can be CL1, CL2. CL1 would be the amount of labor required to produce the first industry, the output of the first industry. CL2 is the amount of labor required to produce 1 unit of good 2. CK1 is the amount of capital required to produce 1 unit of good 1. CK2 is the amount of capital required to produce 1 unit of good 2. So, you also call it input output requirements, or you can say unit labor requirements. So, then you have this 1 and 2 and 3 and 4. If you can solve it using the Cramer method, it would give you So, if you solve for x1 and x2, you can see that x1 is a function of L k2 minus k, k2 minus k1. K is the overall capital labor ratio in this country, k2 is the capital intensity of good 2, k1 is the capital intensity of good 1. So, if you devote your entire capital and labor into the production of k2, then there will be no production of good 1, or if you devote entire capital labor ratio in good 1, there will be no production of good 2. So, your overall capital labor ratio has to lie between k1 to k2. Then only there will be something called incomplete specialization. There will be, in other words, there will be production of both goods x1 and x2. So, if the assumption is this, then it leads to incomplete specialization, wherein there is a production of both goods x1 and x2. So, that is an important assumption, that we are not assuming that x1 is 0 or x2 is 0 or both are 0. We are assuming that in this economy there is production of both goods. So, and the overall capital labor ratio lies from this k1 to k2, where k1 and k2 are the capital intensities in good 1 and good 2. Now, this is after solving 1 and 2. Similarly, you can solve for W and R from 3 using 3 and 4. So, from 3 and 4, so then from here W and R, you can always get W by R ratio, which is this can be written as P1 Ck1 Ck2 by Ck1 minus P2 by P1 Cl1 P1 P2 by P1 minus Cl2 by Cl1. Now, what is to be seen is that W by R eventually will become a function of P only, where P is P2 by P1. Reason being that this Cij, that is input output requirement, is a function of the W by R ratio and technology. So, these are a function of omega, Ck2, Ck1, Cl2, Cl1, they are all functions of omega. Now, if you assume technology to be constant, you will see that W by R will become a function of P only, because these input labor requirements or input capital requirements, they are a function of omega. Why? Because if omega changes, if the W by R ratio in a firm changes, then the capital labor requirements also changes. So, then there is one-to-one correspondence between omega and P. And when we proved the Heckscher-Ohlin theorem, this was one of the basic assumptions, that there is one-to-one correspondence between omega and P. Please recall the diagram that we made for proving the Heckscher-Ohlin theorem using the factor price definition. Now, the assumption, if you have to prove the Heckscher-Ohlin theorem using the factor price definition, the factor price definition is that if W by R in A is less than W by R in B, this means A is labor rich and B is capital rich. A is labor rich because it has a lower relative wage rate, B is capital rich because it has a higher relative wage rate. Now, because there is one-to-one correspondence between relative prices and the relative wage rates, you can see that it is very easy to prove the Heckscher-Ohlin theorem, which says that the country which is rich in capital will export capital intensive product, and country which is rich in labor will export labor intensive product. This is a crude form of the Heckscher-Ohlin theorem. A refined form is of Heckscher-Ohlin is that a country exports the good which uses intensively its abundant factor and imports the good which uses intensively its scarce factor. Now, to prove the Heckscher-Ohlin theorem, you need to show that there is one-to-one correspondence between Px, Py and W by R. Now, you can see that we had proved that there is W by R is a function of P. So, see if W by R increases, you would see that the relative price of X, which is X is a labor intensive product, it also goes up, because X is a labor intensive product. If the relative wage rates go up, the prices will go up. Now, that is enough to prove the Heckscher-Ohlin theorem. You can see good X is labor intensive, good Y is always capital intensive. So, then if this is the before trade situation, Px by Py in A would be less than Px by Py in B. So, the relative wage rates in A is less than relative wage rates in B. This implies that the relative prices in A is less than the relative prices in B. This is because there is one-to-one correspondence between relative prices and relative wage rates. If this is so, A has a comparative advantage in production of good X, because it can produce X at a lower relative price. Lower relative price means lower opportunity cost. So, A will export good X. A is labor rich, so it will export good X. X is a labor intensive product. So, this proves the Heckscher-Ohlin theorem. A, which was labor rich, will export the labor intensive product. B, which is capital rich, will export the capital intensive product. Why? Because the international prices will be determined and they will be somewhere in the middle of Px by Py A and Px by Py B, and you can see eventually what will happen will that with trade you would have the same relative prices and you would have the same relative wage rates. This is also called the factor price equalization. This is another offshoot of the Heckscher-Ohlin theorem. Besides the Stopler-Samuelson and the Rybczynski, the another offshoot of the Heckscher-Ohlin model is that with trade you will see that the relative wage rates will be the same across countries, because the relative prices will be the same, and this is all happening because there is one-to-one correspondence between relative prices and relative wage rates. So, that is where mathematically that is where it is coming. And what is important is that to happen, there needs to be incomplete specialization, there needs to be production of both goods X and Y. That is important. You have this only when there is production of both goods, good 1, good 2, because then only the relative prices are determined. So, incomplete specialization will lead to such results, that there is one-to-one correspondence between relative prices and relative wage rates. So, this is the this is how one can get the values of x1 and x2 and w and r. Now, let us work on the equations of change, because those equations for change will ultimately lead us to the proof of the Stopler-Samuelson theorem and the Rybczynski theorem. What Stopler-Samuelson? A rise in price of a commodity raises the real reward of its intensive factor and a decline in real reward of its unintensive factor. The equations which will be needed will be these, that is 1, 2, 3 and 4. Now, the equations for change so the equations for change would be Cl1 dx1 plus x1 dCl1 plus Cl2 dx2 plus x2 dCl2 is equal to dl, Ck1 dx1 plus x1 dck1 plus Ck2 dx2 plus x2 dck2 is equal to dk. Now, divide by L in the numerator in the denominator throughout, and here by capital in the second equation, further multiply and divide this term by x1, multiply and divide this term with Cl1, multiply this term by and divide by x2, this by Cl2, Cl2, this term by x1, multiply it with x1, divide by x1, Ck1, Ck1, Ck2, sorry, x2, x2, Ck2, Ck2. So, see from what you get from the first, treat this as dx1 by x1, this is the proportionate change in x1. So, you left with x1 L1 by L, Cl1 by L. Cl1 is the unit labor requirement to produce the first industry. So, L1 by x1 into x1 by L. So, you get L1 by L, the proportionate amount of labor which is used in the first industry. Call that as lambda L1 x1 star plus, now dCl1 by Cl1 is the proportionate change in Cl1. So, this would become lambda L1 Cl1 star, this would become lambda L2 x2 star, this would become lambda L2 Cl2 star, and this is L star. So, you have this equation. From here you would get lambda K1 x1 star plus lambda K1 Ck1 star plus lambda K2 plus lambda k2 x2 star plus lambda k2 ck2 star is equal to k star. Now, what is lambda ij? I is L, k, j is 1 and 2. So, say for example, if it is lambda L1, this is L1 by L, lambda L2, this is L2 by L, lambda K1 is K1 by K, lambda K2 is K2 by K, is the proportionate share. L1 by L is the proportionate share, L2 by L is the proportionate share. So, you have lambda L1, lambda L2, lambda K1, lambda K2, right. So, we will work on equation 3 and 4 also similarly, equations of change. If you work on this 3 and 4, you will finally prove Stop-Less-Hamilton. If you work on this, you will prove Rybinski theorems. In fact, if you have read about linear programming, there is something like a primal problem and a dual problem. These two are related in that way. One is a primal and the other is the dual of that. In any case, and then remember the different theorems of LP, which shows that the value of outputs or the value of the objective functions, whether you solve a primal or a dual, works out to be the same. In any case, we are not going into it, we will do a lot of algebra here. So, lambda L1 x1 star plus lambda L2 x2 star is L star minus lambda L1 CL1 star plus lambda L2 CL2 star, and this is lambda K1 x1 star plus lambda K2 x2 star, this is K star minus lambda K1 CK1 star plus lambda K2 CK2 star. Now, further this Cij, recall this is the input output requirement, the unit labor requirement, the unit capital requirement. This is a function of omega and T. T is the technology, omega is W by R, T is technology. So, then if you take dCij, the total differential, this becomes this divide by Cij Now, what it depicts is that this input output requirements, this changes because of the changes in omega, keeping technology constant. This input output requirement changes because of the technology, keeping the relative wage rates constant. Yesterday, when we were discussing the impact of technology, we saw that with technology you have less units of labor and capital producing the same output. So, then we define technology in three ways. it was labor using, another was capital using, and the third was Hicks neutral. In labor using, we saw that the marginal productivity of labor increases by a factor greater than the marginal productivity of capital. Marginal productivity of labor is the increase in MPL is greater than the increase in MPK. As a result, W by R ratio increases. That is called labor using technology. There is something called capital using technology when the MPK, the increase in MPK is greater than the increase in MPL. If the increase in MPL is equal to the increase in MPK, we call it the Hicks neutral technological progress. Whatever it may be, whichever technology it is, at the end you have less units of both capital and labor producing the same level of output. So, technology tends to have an impact on the labor capital requirements to produce 1 unit of output. And then this also changes, because if the relative wage rate change, they also have an impact on Cij. So, this is reflected in this. Now, finally, what comes out is that Cij star, which is the proportionate change, this is equal to Aij star minus Bij star. I is Lk, j is 1 and 2, where Aij star is 1 by Cij del Cij del omega d omega, and Bij star is minus Cij del Cij del t dt. Now, you can see that this Bij star, which is a reflection of how technology affects the input output requirements, it comes with a negative sign. Remember, like the law of demand, which says that price and demand are inversely related. So, when you write a formula for elasticity, price elasticity of demand, you write it is the proportionate change in demand divided by proportionate change in price, but there is a negative sign implying that price and demand are inversely related. So, here also technology tends to have an impact on input output requirement, but there is a negative sign implying that with an improvement in technology, you employ less of labor and capital to produce the same output. So, therefore, there is a negative sign. So, then Cij star proportionate change in the input output requirements is Aij star minus Bij star. Now, you can see this, why I am writing Cij star Aij star minus Bij star, because I want to replace this Cl1 star with Al1 star minus Bl1 star, Cl2 star with Al2 star minus Bl2 star, Ck1 star with Ak1 star minus Bk1 star, Ck2 star with Ak2 star minus Bk2 star. But further, we need to work on also the fact, couple of things, that sigma 1, that is the elasticity of substitution, and sigma 2 you need to understand this elasticity of substitution, which says what is the change in the capital labor ratio as the relative wage rate changes. Now, you can write this as dk1 by k1, where small k1 is k1 big K1 divided by L1. Now, you do dk1 by L1 divide by k1 and use the quotient rule of derivative. Please recall the quotient rule of derivative. If you have to find dk1, if you use the quotient rule, it will be L1 dk1 minus k1 dL1 divided by L1 square. And then if you divide by k1, you will get proportionate change, you will get a proportionate change in k1, proportionate change in labor. So, k1 star minus L1 star, W star minus R star. Now, you can write this as k1 star minus x1 star minus L1 star minus k1 star. So, this is ak1 star. Please recall ak1 star, it is the change of the input output requirements due to changes in the omega. Omega is the W by R ratio. So, here keeping technology constant, this becomes ak1 star, this is al1 star, this is ak2 star minus al2 star divided by W star minus R star. So, we will remember this relationship, that sigma 1 is equal to that, sigma 2 is equal to ak2 star minus al2 star divided by W star minus R star. Further, if you recall in perfect competition, you operate at the minimum of the long run average cost. So, this requires that W CL1 plus R CK2 R CK1 differential of this should be equal to 0. Why? If you are operating at the minimum of this, then d average cost dx, the differential of this would be equal to 0, because remember at this point the slope is 0, and this is your total cost of producing good 1. This is the total average cost of producing good 1, where CL1 is L1 by x1, CK1 is K1 by x1. So, you get W L1 plus R K1 divided by x1. So, this is the average cost. Now, you are operating at the minimum of this average cost. So, this should hold. If this holds, then W dCL1 plus R dCK1 is equal to 0. Now, you can always divide by CL1, multiply by CL1, divide by CK1, multiply by CK1. So, you get W CL1 CL1 star plus R CK1 CK1 star. Now, here we are assuming technology to be same. So, if you want to study the dCL1 by CL1 star when technology remains the same, then this CL1 star will be replaced by AL1 star and this would be replaced by AK1 star. Further, divide by P1. So, what you get is from here W L1 P1 x1 AL1 star plus R K1 P1 x1 AK1 star equal to 0. Now, this is theta L1 AL1 star plus theta K1 AK1 star equal to 0. Now, do a similar thing. By minimizing the average cost of producing good 2. So, in that case dWCl2 plus RCK2 is equal to 0. So, you will get WdCl2 plus RdCK2 equal to 0. So, Cl2 Cl2 CK2 CK2. So, you get WCl2 Al2 star plus RCK2 AK2 star equal to 0. Divide by P2. So, you get theta L2 Al2 star plus theta K2 AK2 star equal to 0. So, you have 1 and 2 and you have this 3 and you have this 4. Now, what you need to do is to replace the value of AK1 star from here and see what you get as sigma 1. Then you need to replace the value of AL1 star from this. Then you need to replace the value of AL2 star from here. Then you need to replace the value of AK2 star from here. And then we need to get what would be AK1 star, AL1 star, AK2 star, AL2 star in terms of this elasticity of substitution. Once we have that, then we will put it in this CL1 star, CL2 star, CK1 star, CK2 star, and then using this, that CL1 star is AL1 star minus BL1 star, AL1 star, AK1 star, AK2 star, AL2 star will be expressed all in terms of the elasticity of substitution. Once we have that, then we will see that what these two final equations will look like. So, what you will get on the right hand side will be proportionate change in labor, proportionate change in capital, but there will be some term which will express two things, because remember Cij star, this is input output requirement, this is a function of omega and t, and you are saying that this is changing. So, this can change because of the change in omega, and this can change because of the change in technology. Okay. So, when you talk of Rzybinski, you have two assumptions. If Rzybinski has to hold, that means if you have to establish relationship between output x1 and L, x1, x2 and k, you have to assume there are two important assumptions. One, technology does not change, relative wage rates do not change, because then only you will get a relationship between x's and labor and capital if these things do not change. If these things do not change means omega does not change, technology does not change. So, in many of the interviews they ask what is Rzybinski. So, you have to say that it is a relationship between outputs and factor supplies. Let me repeat what Rzybinski is: an increase in supply of a factor keeping relative prices constant. Relative prices constant means relative wage rates constant, increases the output of the commodity which uses intensively the expanding factor and decreases the production of the other commodity. Now you may ask, where is it used, this Rybinski? Now people say that when people from here migrate to US, the US people say that it will depress wages there because so many people are going there. But here it will tell you, Rybinski tells us that if you increase labor, output of the expanding factor increases, keeping relative prices constant. If relative prices are constant, relative wage rates are constant. So if you can see debates in the parliaments, or that they say that migration anyway is a very tricky issue. In Europe, in US, they say a lot of migration will depress wages, or some illegal migrants are coming from Mexico or from Cuba, that will depress wages in, say, Florida. If you test for Rybinski, you can prove that with an increase in labor, in the long run, output of the commodity which uses intensively that labor, that increases. Prices remain the same, wages remain the same. In fact, there is empirical evidence which shows that as soon as these Cubans migrated, illegally moved to Florida, they had assumed that the wages will go down. That did not happen. In fact, the output went up of the labor intensive product. Similarly, when their skilled people moved from say Russia to Israel, it was feared that it will depress wages of the skilled workers. It did not. Outputting expanded. So there is an empirical evidence to show. So if you go and read the literature on Rybinski, you will see that there are so many interesting applications of Rybinski. So tomorrow we will see how once we have established this, how AK1 star, AL1 star, AK2 star, AL2 star will become a function of sigma 1, sigma 2. Once it is here, then you can replace it here. You will get an equation which will reflect not only this relationship between x1 and L star, but you will have some term which will show the change of Cij due to change in omega, a change in Cij due to change in T. So for Rybinski, then you have to further assume that those are constant. Then if you work on it, you just have to find, using Cramer method, value of x1 star and x2 star. You can easily prove the Rybinski, that with an increase in supply of a factor, output of the good which uses the expanding factor intensively will increase, and there will be a decline in production of the other commodity. So this is with, if you work with this equation, you will prove the Rybinski. If you work with equation 3 and 4, which is a relationship between relative wage rates and relative price, you will get the Stopler-Samuelson theorem. Again, on the right hand side, you will see a term which will reflect technology. So if you have to prove Stopler-Samuelson theorem, you have to prove that the technology remains the same. Then you will find a link between the relative wage rates and the relative prices. So again, you will find the Cramer method, we will get the value of W star, R star, and then it will be very easy to prove the linkage between the two prices, product prices and the factor prices, that is Stopler-Samuelson. Physical relationship between output and labor, that is Rybinski. Okay. So we will meet tomorrow. Thank you so much.